Implementation of AI-driven drone technology in Ukraine by Q2 2024. 1. Introduction. The ongoing conflict in Ukraine has underscored the pressing need for advanced technological solutions in modern warfare. In response, a significant initiative is set to be launched focusing on the implementation of AI-driven drone technology in Ukraine by the second quarter of 2024. This project, with a budget of $15 million, will unfold across 4 key phases: hardware integration, software development, regulatory compliance, and operational training for local forces. 2. Overview of the project phases. The initiative is structured into the following 4 phases. Phase 1. Hardware integration. In this initial phase, advanced drone systems will be integrated into the existing military frameworks of Ukraine. This step is crucial to ensure compatibility and functionality with the Ukrainian defense infrastructures. The integration will involve assessing current capabilities and determining the necessary hardware upgrades to accommodate AI-driven features. Phase 2. Software development. The second phase focuses on the development of artificial intelligence algorithms designed to enhance drone functionalities such as targeting, navigation, and real-time decision-making. The objective is to leverage AI to improve threat assessment capabilities, enabling drones to operate more effectively in combat scenarios. This phase will also involve extensive testing to ensure reliability and performance under various conditions. Phase 3. Regulatory compliance. Adhering to national and international regulations is critical for the successful deployment of drone technology. This phase will involve collaboration with regulatory bodies to secure necessary approvals for drone operations in both military and civilian airspaces. This compliance will ensure that the implementation aligns with legal frameworks governing drone usage in combat situations. Phase 4. Operational training. The final phase of the project will focus on training local forces to operate and maintain the newly integrated drone systems effectively. This training is vital for empowering Ukrainian military personnel with the skills needed to leverage this advanced technology in combat scenarios. It will encompass both theoretical knowledge and practical applications, ensuring that local forces can utilize the drone systems to their full potential. 3. Financial backing and use cases. The $15 million budget allocated for this project will be distributed across the 4 phases, with specific portions designated for hardware acquisition, software development, compliance efforts, and training programs. The initiative is expected to significantly enhance the capabilities of Ukrainian forces, particularly in reconnaissance, surveillance, and targeted strikes. Drones have increasingly become essential in modern warfare, and their use in Ukraine has demonstrated their strategic importance. Reports indicate that AI-driven drones can provide real-time intelligence, conduct precision strikes, and perform complex missions that were previously impossible or too dangerous for human operators. 4. Common themes across sources. Multiple sources underline several themes regarding the implementation of AI-driven drone technology in Ukraine. Technological integration. The integration of AI technologies to improve drone functionalities is emphasized across various reports, highlighting the importance of advanced algorithms in enhancing operational capabilities. Geopolitical context. The urgency of deploying these technologies in Ukraine is driven by the current geopolitical landscape, where nations are rapidly advancing their military capabilities amidst ongoing conflicts. Collaboration with local forces. The need for effective training and operational support for local military forces is consistently highlighted as crucial for the successful implementation of drone technologies. 5. Differences and perspectives. While there is consensus on the technological focus and strategic importance of the project, perspectives vary regarding the challenges involved. Some sources emphasize the regulatory hurdles that must be navigated to ensure compliance with international laws, while others focus on the tactical advantages that drones can offer in urban warfare scenarios. 6. Timeline of events. The project's timeline is structured as follows. 2023, initial discussions and planning for the AI-driven drone technology deployment in Ukraine begin, with groundwork laid for hardware and software requirements. Q1 2024, completion of hardware integration and initial software development is expected, setting the stage for subsequent phases. Q2 2024, full operational capability is anticipated, coinciding with the rollout of training programs for local forces in compliance with regulatory frameworks. 7. Conclusion. The initiative to implement AI-driven drone technology in Ukraine represents a significant evolution in modern warfare, combining advanced technology with strategic military training. The successful deployment of this technology will hinge on meticulous planning across all 4 phases, as well as ongoing support for local military forces. By integrating AI capabilities into drone operations, Ukraine aims to enhance its defensive and offensive capabilities, effectively countering emerging threats in the evolving conflict landscape. This strategic investment in drone technology is not only a response to current challenges but also a forward-looking approach to modernize and strengthen the capabilities of the Ukrainian military, ensuring that it remains competitive in a rapidly changing geopolitical environment. As the project unfolds, it will serve as a critical case study in the integration of advanced technologies in military operations, potentially influencing future defense strategies globally. The implementation of AI-driven drone technology in Ukraine by Q2 2024 is a complex initiative that involves multiple phases, a significant budget, and a focus on various aspects of technological integration and operational readiness. Here's a detailed breakdown. 1. Overview and phases. The project consists of 4 key phases. Phase 1, hardware integration, integrating advanced drone systems into the existing military framework in Ukraine. This phase ensures that the new systems are compatible with current defense infrastructures and capable of enhancing operational capacities. Phase 2, software development, developing sophisticated AI algorithms to improve drone functionalities, including targeting, navigation, and real-time decision-making. This phase aims to leverage AI for threat assessment and operational efficiency. Phase 3, regulatory compliance, engaging with national and international regulatory bodies to ensure that drone operations adhere to legal standards. This phase is critical for obtaining necessary approvals and maintaining operational legitimacy. Phase 4, operational training, training local forces to effectively operate and maintain the drones. This training is essential for empowering the military to leverage drone technology in combat situations. 2. Financial backing in use cases. The initiative is backed by a budget of $15 million, which will be allocated across the 4 phases. The funding is expected to significantly enhance Ukraine's drone capabilities. Drones have become a crucial aspect of modern warfare, particularly in Ukraine, where they are used for reconnaissance, surveillance, and targeted strikes. The strategic importance of drones in contemporary military operations cannot be overstated, as evidenced by their growing use in the ongoing conflict. 3. Common themes across sources. Several common themes emerge from various sources discussing this initiative. Technological integration. The emphasis on integrating AI technologies to enhance drone functionalities is a recurring point. This integration is seen as vital for modernizing military capabilities. Geopolitical context. The urgency of deploying these technologies in Ukraine is driven by the current geopolitical landscape, where nations are rapidly advancing their military capabilities in response to emerging threats. Collaboration with local forces. The need for thorough training and operational support for local military forces is highlighted as essential for the successful implementation of drone technologies. 4. Differences and perspectives. While there is broad agreement on the technological focus and strategic importance of the project, some sources differ in their emphasis on regulatory challenges versus operational implementation. For instance, some reports stress the need for adhering to international laws governing drone warfare, highlighting the complexities of regulatory compliance. Others focus on the tactical advantages that drones offer, particularly in urban warfare scenarios, suggesting that immediate operational capabilities may take precedence over regulatory concerns. 5. Timeline of events. A projected timeline for the initiative includes 2023 – Initial discussions and planning for the AI-driven drone technology deployment in Ukraine. Q1 2024 – Anticipated completion of hardware integration and initial software development. Q2 2024 – Expected full operational capability, including the initiation of training programs for local forces and ensuring compliance with regulations. Conclusion. The implementation of AI-driven drone technology in Ukraine is a transformative initiative that combines advanced technology with strategic military training. The success of this deployment will depend on meticulous planning across all phases and ongoing support for local military forces. This initiative aims to equip Ukraine to effectively counter emerging threats in a rapidly evolving conflict landscape. Counterintuitive information. 1. Regulatory compliance versus operational readiness. There is often a belief that regulatory compliance is a straightforward process, but the urgency of military needs can sometimes overshadow these requirements, leading to potential conflicts between compliance and immediate operational demands. This scenario can create a tension where military effectiveness might initially take precedence over regulatory adherence. 2. Budget allocation discrepancies. While $15 million may seem substantial for a military initiative, in the context of advanced drone technology and its integration into existing systems, this budget might be perceived as inadequate by some analysts, who highlight the rapid technological advancements and the need for ongoing funding to keep pace with evolving threats. 3. Training importance. It may be counterintuitive to suggest that training local forces is as critical as the technology itself. However, without proper training, even the most advanced drone systems may fail to achieve their intended operational impact, emphasizing that technology alone cannot guarantee success in military applications. For geopolitical context, the urgency to deploy such technologies in Ukraine might seem primarily driven by the immediate conflict, but it also reflects broader trends in global military modernization, indicating that the lessons learned from Ukraine are likely to influence military strategies worldwide. 5. Dependency on AI. While AI is often viewed as a game-changer in military technology, there is a counterintuitive risk that reliance on AI-driven systems could lead to vulnerabilities, especially if adversaries develop countermeasures specifically targeting these technologies. This highlights the need for a balanced approach that considers both technological advantages and potential risks. In the report regarding the implementation of AI-driven drone technology in Ukraine, several critical aspects are highlighted that may be overlooked yet hold substantial significance. Here's a detailed exploration of those overlooked elements and their implications. 1. Regulatory compliance. While the project phases include a mention of regulatory compliance, many may underestimate its importance. This phase is not just a bureaucratic hurdle. It involves navigating complex legal frameworks both nationally and internationally. The significance lies in the potential for operational delays, legal ramifications, and the need for ongoing adaptation to evolving drone regulations as countries tighten their laws around military drone usage and AI technologies. This compliance phase ensures that Ukraine's use of these technologies does not violate international laws, which could lead to diplomatic fallout or sanctions. Significance. The regulatory landscape for military drone operations is fluid and can drastically change based on geopolitical tensions. Failure to comply could result in operational halts or legal challenges that impede the entire initiative. Moreover, compliance can serve as a model for other nations looking to implement similar technologies, thus influencing global standards. 2. Operational training for local forces. The inclusion of operational training for local forces as a phase in the implementation plan is often viewed merely as a logistical necessity. However, the significance of this training cannot be overstated. It is essential for ensuring that local military personnel can effectively utilize the advanced capabilities of AI-driven drones in combat scenarios. The training will likely encompass not only the technical aspects of drone operation but also tactical applications in real-world conflicts, which can vary significantly from theoretical training. Significance. This phase is crucial for fostering self-sufficiency within the Ukrainian military. Proper training can enhance operational effectiveness and reduce reliance on external support. Furthermore, it can empower local forces to adapt the technology to their specific needs in combat situations, ultimately leading to a more resilient defense posture. 3. Hardware integration challenges. The first phase of hardware integration may seem straightforward, but it encompasses significant challenges that are often overlooked. Integrating advanced AI-driven drone systems into existing military frameworks requires not only technical compatibility but also strategic alignment with current military operations. Issues such as legacy systems, interoperability with existing equipment, and adaptation to unique operational environments must be addressed. Significance. Successful hardware integration is pivotal to the overall effectiveness of the drone technology initiative. If integration fails, it could render the investment in AI-driven drones ineffective, wasting resources and potentially compromising operational capabilities. A well-executed integration phase can also provide valuable lessons for future military technology implementations. 4. AI algorithm development. The focus on AI algorithm development within the software development phase is another aspect that merits deeper consideration. This phase is critical as it determines how effectively drones can perform tasks such as targeting, navigation, and real-time threat assessment. The development of robust AI algorithms that can operate in complex environments with unpredictable variables is a formidable challenge that requires significant expertise and resources. Significance. The effectiveness of drone technology in combat scenarios hinges on the sophistication of its AI algorithms. Poorly developed algorithms could lead to misidentifications, tactical errors, and potential collateral damage, which may have broader implications for military strategy and public perception. The success of this phase is crucial for establishing trust in the technology among military personnel and policymakers. 5. Geopolitical context and urgency. The implementation of AI-driven drone technology is taking place against a backdrop of ongoing conflict in Ukraine, which adds a layer of urgency to the project. The geopolitical climate influences not only the timeline but also the operational parameters within which these drones will be deployed. The fast-paced nature of warfare today demands that technological advancements keep pace with the evolving tactics of adversaries. Significance. The urgency of this project reflects the broader context of modern warfare, where technological superiority can decisively impact outcomes. This urgency necessitates streamlined processes and rapid adaptation, with potential ramifications for international relations and military strategy. The project's success could reshape the military capabilities of Ukraine and serve as a model for other nations in similar situations. 6. Budget allocation and financial oversight. The $15 million budget allocation across the 4 phases may seem adequate at first glance. However, the detailed oversight and management of this budget are critical for the project's success. Misallocation of funds or unforeseen expenses could derail individual phases and jeopardize the overall implementation timeline. Significance. Financial management is a key determinant of project success. Ensuring that funds are allocated efficiently and effectively will maximize the impact of the investment in AI-driven drone technology. Furthermore, transparency and financial oversight can build trust among stakeholders, including government officials, military personnel, and external partners. Conclusion. The implementation of AI-driven drone technology in Ukraine is a multifaceted endeavor that extends beyond mere technological deployment. The importance of regulatory compliance, operational training, hardware integration, AI algorithm development, geopolitical context, and budget management are all critical factors that can significantly influence the project's outcome. Recognizing and addressing these often overlooked aspects is essential for ensuring a successful integration of this advanced military capability, ultimately enhancing Ukraine's defense efforts in a challenging geopolitical landscape. The implementation of AI-driven drone technology in Ukraine by Q2 2024 involves a comprehensive strategy with a budget of $15 million segmented into 4 key phases. Each phase addresses critical aspects of integrating this advanced technology into the Ukrainian military framework. Below are the 4 most valuable points for in-depth analysis and discussion. 1. Phased implementation strategy. The project is structured around 4 distinct phases. Phase 1, hardware integration, focuses on incorporating advanced drone systems into the existing military infrastructure of Ukraine. This phase ensures that the new technology is compatible with current defense capabilities, addressing logistical and operational challenges that may arise during the integration process. Phase 2, software development, aims to create sophisticated AI algorithms that enhance drone functionalities, particularly in targeting and navigation. The AI will enable real-time decision-making and threat assessment, which are crucial for effective military operations. This phase's emphasis on software underscores the growing importance of artificial intelligence in modern warfare. Phase 3, regulatory compliance, is essential for ensuring that drone operations adhere to both national and international laws. This phase involves working closely with regulatory authorities to secure necessary approvals, which can be a significant hurdle in the deployment of military technology. The focus on compliance reflects the need for ethical considerations in warfare and the legal ramifications of using drones. Phase 4, operational training for local forces, is critical for the successful adoption of the technology. Training ensures that military personnel can operate and maintain the drones effectively, maximizing their utility in combat scenarios. This phase emphasizes the importance of human capital and technological advancements, as skilled operators are essential for leveraging the capabilities of AI-driven drones. 2. Financial allocation and use cases. The $15 million budget allocated for this initiative will be distributed across the 4 phases with specific goals tied to each expenditure. This budget is expected to significantly enhance the operational capabilities of Ukrainian forces, especially in light of the ongoing conflict. Use cases: drones are increasingly utilized for reconnaissance, surveillance, and targeted strikes, demonstrating their strategic importance in modern warfare. The successful implementation of this technology in Ukraine could serve as a model for other nations involved in similar conflicts, particularly in terms of maximizing military efficacy through technological integration. 3. Geopolitical context and urgency. The urgency behind deploying AI-driven drone technology in Ukraine is heavily influenced by the current geopolitical landscape. The ongoing conflict has highlighted the need for advanced military capabilities to counter emerging threats effectively. Technological race: the rapid advancement of military capabilities among nations necessitates a swift response from Ukraine. The initiative to implement AI-driven drones is not merely a technological upgrade, it is a strategic move to enhance national defense and maintain parity with adversaries who are also advancing their military technologies. Collaboration and support: this project signifies international collaboration and support for Ukraine, showcasing a unified effort to bolster its defense capabilities. The geopolitical context underscores the significance of technological enhancements in achieving military objectives and ensuring national security. 4. Common themes and divergent perspectives. The analysis of various sources regarding the implementation of AI-driven drone technology reveals several common themes as well as differing perspectives on prioritization. Technological integration: there is a consensus on the necessity of integrating advanced AI technologies to improve drone functionalities. This highlights a broader trend in military modernization efforts where technology plays a central role in operational effectiveness. Regulatory challenges versus operational implementation. While most sources agree on the importance of regulatory compliance, some emphasize the challenges posed by international laws governing drone warfare more than others. This divergence points to the complexity of military operations in a legal framework, where ethical considerations must be balanced with tactical advantages. Conclusion: the implementation of AI-driven drone technology in Ukraine by Q2 2024 represents a multifaceted approach to modern military operations. It encapsulates the need for technological advancement, strategic planning, and adherence to regulatory frameworks. The successful execution of this initiative could not only enhance Ukraine's defense capabilities but also set a precedent for future military innovations in conflict zones globally. The discussions around this initiative will likely evolve as the geopolitical landscape continues to shift and as the operational realities of drone warfare become more pronounced. 1. The Manhattan Project 1942–1946. This was a secret U.S. project during World War II focused on the development of atomic weapons. Funded by the U.S. government, the Manhattan Project represented a massive investment in technology and human resources involving collaboration among scientists, military personnel, and government officials. The project was divided into key phases, including research and development with a significant budget allocated to various components such as infrastructure and technological innovation. Ultimately, it led to the creation of the atomic bomb, fundamentally changing the landscape of warfare and international relations. 2. Operation Desert Storm 1991. This operation was part of the Gulf War and marked a significant technological advancement in warfare, particularly with the use of precision-guided munitions and UAVs, unmanned aerial vehicles. The U.S. military utilized advanced technology to conduct airstrikes and gather intelligence, demonstrating the importance of integrating new technologies into military operations. The successful execution of the operation involved extensive planning and a substantial budget allocated to various phases, including preparation, execution, and post-war assessments. 3. The Apollo Program 1961–1972. The Apollo program was a series of space missions aimed at landing humans on the Moon and returning them safely to Earth. Spearheaded by NASA. The program involved significant investment in technology research and training. The initiative was divided into various phases, including the design and construction of spacecraft, astronaut training, and mission execution. The Apollo program not only achieved its goal of landing on the Moon but also advanced numerous technological fields, contributing to subsequent space exploration and technology development. The collaboration of scientists, engineers, and astronauts exemplified the transformative impact of integrating advanced technology into ambitious projects. Future outlook: AI-driven drone technology in Ukraine. As the implementation of AI-driven drone technology in Ukraine progresses through its 4 key phases by Q2 2024, there are several predictions and implications to consider, particularly in the context of military strategy, technological innovation, and geopolitical dynamics. 1. Enhanced military capabilities. By Q2 2024, the integration of advanced drone systems into Ukraine's military infrastructure is expected to significantly enhance operational efficiency. The following outcomes can be anticipated. AI-enhanced surveillance and reconnaissance. Drones equipped with AI algorithms will provide real-time data analysis, improving situational awareness on the battlefield. This capability will enable Ukrainian forces to identify threats more effectively and coordinate responses swiftly. Targeted strikes and combat effectiveness. AI-driven targeting systems will allow for more precise strikes, reducing collateral damage and increasing the effectiveness of military operations. This technological edge will be crucial in urban warfare scenarios where civilian populations are at risk. Increased autonomy. As local forces become proficient in drone operation and maintenance, the ability to deploy drones autonomously for reconnaissance or offensive missions will become more common. allowing for greater operational flexibility. 2. Technological innovation and development. The project's emphasis on software development and AI integration is likely to spur further advancements in drone technology beyond initial deployments. Expected trends include rapid iteration and improvement. The feedback loop from operational use will facilitate rapid iterations of software and hardware, fostering innovation in drone capabilities. This could lead to enhancements in battery life, payload capacity, and sensor technology. Collaboration and knowledge transfer. The partnership between Ukrainian forces and technology providers will likely create a robust framework for knowledge transfer, enhancing local expertise in drone technology and fostering a domestic industry for drone production and maintenance. Emergence of new applications. The successful application of drones in military contexts may lead to their adoption in civilian sectors, particularly in agriculture, surveillance, and disaster response, leading to a broader economic impact. 3. Geopolitical implications. The AI-driven drone initiative in Ukraine is set against a backdrop of heightened geopolitical tensions, particularly with Russia. This context will shape several outcomes. Shift in military balance. The enhanced capabilities of Ukrainian forces may alter the military balance in the region, prompting shifts in strategies from adversaries. This could lead to an arms race in drone technology among neighboring countries. Influence on international relations. Successful implementation of drone technology may strengthen Ukraine's position in international negotiations, as demonstrated military effectiveness could lead to increased support from Western allies in terms of arms and financial aid. Regulatory challenges. As drone technology evolves, regulatory compliance will become increasingly complex. Navigating both national and international regulations will be critical to ensure that drone operations remain within legal frameworks, particularly concerning warfare ethics and civilian safety. 4. Training and operational readiness. The operational training phase is crucial for the successful deployment of AI-driven drones. Predictions for training and readiness include rapid skill acquisition. Local forces are likely to achieve operational readiness faster than anticipated due to the hands-on nature of drone operation training combined with advanced simulation technologies. Continuous learning and adaptation. Ongoing training programs will be essential as drone technology evolves. This will require a commitment to continuous education and adaptation to new challenges and technologies. Building a culture of innovation. The integration of drones into military operations will cultivate a culture of innovation within the Ukrainian military, encouraging personnel to explore new tactics and technologies. Conclusion. The implementation of AI-driven drone technology in Ukraine by Q2 2024 is poised to transform military operations, catalyzing advancements in technology, reshaping geopolitical dynamics, and enhancing operational readiness. As Ukraine navigates these changes, the outcomes will not only influence its military capabilities but also contribute to the broader discourse on the future of warfare and international relations in an increasingly complex global landscape. The $15 million investment in this initiative represents a critical step toward leveraging technology for strategic advantage, with potential ramifications that extend far beyond the immediate conflict.